Hello, this is Jack Jackson. Let's look at another example of finding the volume of a solid where the cross section is some similar figures, and it's something easy to figure out the area of. Like this time we're going to use a rectangular cross section. So see if you can work this one out. Find and illustrate the volume of solid with a base in the XY plane bounded by the curves y equals x and y equals the square root of x minus 2, x equals 3, and x equals 6. And the cross sections parallel to the y-axis and perpendicular xy plane, in other words, for slices for constant x, are rectangles with a height twice the base. The base is the length in the xy plane. It's actually the base of the figure is where it's in the xy plane, and the base of the rectangles are in the xy plane. Find the exact value in fractional and decimal form, and you can use this activity right here following this link to help illustrate it. See if you can work this one out yourself and come back when you think you have an answer. Check it against what we're going to do next. Press pause now. We'll have two illustrations. The one on the left is just the illustration of what's happening in the xy plane for the base. The bottom curve is the square root of x minus 2 between 3 and 6, and the top curve is just y equals x from 3 to 6. And then the shaded area there is the flat base of one side of the figure. That'll be the face that's down in the xy plane, which is the bottom of the picture you see on the right. The picture on the right was produced by this application, and I said the upper curve was x, f of x is x, lower of x was square root of x minus 2. We're going from a equals 3 to b equals 6. If we slide this slider right here, it will slide where this cross section is, which is always going to be a rectangle. So the base here of the rectangle is this length here, f minus g. That is x minus the square root of x minus 2. And the height is twice that. So the base is x minus the square root of x minus 2. The height is 2 times x minus the square root of x minus 2. And then the thickness is going to be dx. Well, delta x approximating with a little prism. A bunch of those prisms, adding them up, that's a Riemann sum. Take the limit as delta x goes to 0 and the number of the prisms goes to infinity. And that thickness basically becomes our dx here. And we're integrating from 0 to 6. So that definite integral is going to give you the area that we were looking at. I'm going to leave the 2 out for the moment and multiply this binomial times itself. Do FOIL to distribute. X times x is x squared. Square root of x times square root of x minus 2 times square root of x minus 2 is x minus 2. Two negatives multiply together to be positive. And for the middle term, you multiply and double it because the o and the I are the same. They double up. So it's minus 2x square root of x minus 2. And I'm going to just bring the polynomial part in the front, put the square root at the back, and distribute the 2. So I get 2x squared plus 2x is minus 4, and then minus 4x times x minus 2. Square root of x minus 2 there. And then I can go ahead and do the integral, at least of the polynomial part. The power goes up here 1 to 3 divided by the new power, so that antiderivative is 2/3 x cubed for the first term. The next one, the power goes up to 2 divided by 2 is just x squared. The negative 4 picks up an x. And for this part, I'm going to do a substitution. I'm going to let u be x minus 2. That means x is u plus 2 and du is dx. So the dx here becomes du, that should say. Let's fix that real fast. I switch to u's, so that's a u there and there. Okay. Now at the end, I'm going to evaluate from x equals 3 to x equals 6. Okay, so where were we? We're right here. I can distribute the u to the 1/2 times this and get u to the, and I'm going to distribute the negative 4 as well. Negative 4 times u to the 3/2 and negative 8 times u to the 1/2. All right, well now that's just a polynomial, well not a polynomial, but a sum of power functions, so it works kind of like a polynomial does. You just add 1 to the power. 3 halves plus 1 is 3 halves plus 2 halves is 5 halves. Multiplied by the reciprocal, so 2 fifths times -4 is -8 fifths for the coefficient. Similarly, this one goes up 1 half plus 1 is 1 half plus 2 halves is 3 halves. 2/3 times -8 is -16 thirds. Now we're ready to evaluate from 3 to 6. Well, not quite. I need to make these u's back into x's. U is x minus 2, so I'll replace that there and there. Now we can go ahead and evaluate. Taking this expression, put in a 6, minus the same expression, put in a 3 in place of x. So that's what we have here, and then just simplify some arithmetic now. 6 cubed times 2/3 is 144. 6 squared is 36. -4 times 6 is -24. 6 minus 2 is 4. The 1/2 power of 4 is 2. Then to the 5th is 32 times -8 fifths is -256 fifths. 6 minus 2 again is 4. The square root of that is the 1/2 power there, so that's going to be 2. To the 3rd is 8. 8 times -16 thirds is -128 thirds. We're going to distribute the minus here. 3 cubed is, well, one of the 3's cancels here. So you've got 3 squared is 9 times 2 is 18, and it's negative because of that. 3 squared is 9, but now that negative makes it negative. That's -12, but that negative makes it +12. 3 minus 2 is 1. 1 to any power is 1. So here we just have the -8 fifths, and that negative makes it +8 fifths. Similarly, that's 1. So we're going to have +16 thirds there. Now you just get a common denominator and add all this together. I'd probably, if I were doing it by hand, I would probably go ahead and add all of the constant integers first. 146 plus 144 plus 36 minus 24 minus 18 minus 9 plus 12. And I'd probably add these with the fifths together and then the thirds together. But then you still got a whole number and so many fifths and so many thirds. You get a common denominator of 15 and get those together. I left out the details of that here. You can work that by hand on your own or just plug it in a calculator. And you get 811 over 15, which in decimal form is 54.06 with the 6 repeating. And here's a check here on a TI Nspire. It does it exactly. I went ahead and wrote that with the squared instead of writing that one twice. But anyway, that's 811 over 15, or approximately 54.06 repeating with the 6 repeating there. All right, there's a good example of that. Let's do some more next time.